NEC 110.34.F states, electrical equipment shall be installed and protected so as to minimize the possibility of a fire originating within or from the equipment. This section requires that electrical equipment be protected from fire hazards, including the potential for water damage from sprinklers. The fire marshal's requirement for sprinklers in the electric room is intended to minimize the risk of fire. By requiring a protective hood over the main distribution panel, the electrical inspector is upholding NEC 110.34.F by protecting the main distribution panel from water damage and potential fire hazards. The electrical inspector's argument that the hood must be removed is based on a different interpretation of NEC 110.34.F. They believe that the main distribution panel must be included in the area protected by sprinklers to ensure full fire protection. However, this interpretation does not necessarily conflict with the fire marshal's requirement, as the hood provides additional protection to the main distribution panel while still allowing it to be included in the sprinkler coverage area. To resolve this dilemma, consider the following options. Firstly, reinstall the hood with sprinkler head. Secondly, use a NEMA 3R rated main distribution panel. And thirdly, negotiate with the electrical inspector. Let's dive into each option. Firstly, consider reinstalling the hood with sprinkler heads. This involves installing a sprinkler head on the underside of the hood to ensure fire protection while maintaining protection from water damage. Secondly, consider using a NEMA 3R rated main distribution panel. Install a main distribution panel that is rated NEMA 3R, which is designed to withstand water spray. This will eliminate the need for a protective hood. Thirdly, negotiate with the electrical inspector. Explain the reasoning behind the fire marshal's requirement for a hood and discuss the possibility of installing sprinkler heads on the underside of the hood to satisfy both requirements. Ultimately, the decision of whether the hood should be removed or not should be made in consultation with both the fire marshal and electrical inspector. The goal should be to comply with both requirements and provide a safe and compliant electrical installation. Reviewing the code requirements more specifically, the purpose of 110.34.F is to ensure electrical equipment is installed and protected to minimize fire risks, whether originating from within the equipment or externally. The installation of the hood was likely intended to mitigate water damage from the sprinkler system, which could lead to electrical faults and potential fires, thereby aligning with the intent of 110.34.F. However, the disagreement arises from differing interpretations of how best to achieve this protection. Consider the potential for a fire originating within the main distribution panel itself. The electrical inspector's concern might be that the hood could impede the sprinkler system's ability to suppress a fire originating inside the panel. In this case, the hood, while protecting from external water sources, could hinder internal fire suppression, potentially violating the broader intent of 110.34.F to minimize all fire possibilities. The installation of a sprinkler head inside the hood, directed towards the equipment, addresses this concern. This ensures that a fire originating within the main distribution panel would be quickly suppressed by the sprinkler system, while the hood continues to provide protection against water damage from the overhead sprinkler system. The NEMA 3R rating signifies that the enclosure is designed to provide a degree of protection against rain, sleet, snow, and dripping water. If the main distribution panel is NEMA 3R rated, it inherently offers a level of protection against water ingress, potentially eliminating the need for an additional hood. This could satisfy both the fire marshal's concern for fire risk minimization and the electrical inspector's interpretation of 110.34.F. Engage in a constructive dialogue with both the fire marshal and the electrical inspector. Present the different options, such as the installation of sprinkler heads within the hood or the use of a NEMA 3R rated main distribution panel, and discuss the pros and cons of each in relation to 110.34.F. Emphasize the goal of achieving a solution that satisfies both fire safety and electrical code requirements. A compromise might involve a combination of approaches, such as using a NEMA 1 enclosure with internal sprinkler protection. In some instances, a formal interpretation from the relevant code authority may be necessary to resolve conflicting interpretations. Requesting a formal interpretation can provide clarity and guidance for future installations, ensuring consistent application of the code. Ensure that all proposed solutions comply with other relevant sections of the National Electrical Code, such as those pertaining to working clearances, accessibility, and ventilation. The solution should not introduce new hazards or compromise the functionality of the electrical equipment. Document all discussions, decisions, and justifications for the chosen solution. This documentation can be valuable for future reference and for demonstrating compliance with the code to other stakeholders. Consider engaging a qualified electrical engineer to assess the situation and provide a professional opinion on the most appropriate solution. An engineer can offer a comprehensive analysis of the electrical system and provide recommendations that are both safe and compliant. Beyond NEC 110.34.F, other sections of the National Electrical Code could be relevant depending on the specific installation. These might include requirements for overcurrent protection, grounding, and wiring methods. Ensure that the chosen solution complies with all applicable code requirements. Confirm that the sprinkler system design and installation comply with relevant fire codes and standards. This includes ensuring proper sprinkler head spacing, water supply, and alarm systems. Verify that the hood itself is constructed of non-combustible materials and does not impede access to the electrical equipment for maintenance and repair. The design should also allow for adequate ventilation to prevent overheating of the equipment. If modifications are made to the electrical system or the sprinkler system, ensure that proper permits are obtained and that inspections are conducted by the relevant authorities. This helps to ensure that the work is performed in accordance with the code and that the installation is safe. It's important to consider the long-term maintenance and reliability of the chosen solution. The system should be designed to be easily maintained and inspected, and any potential failure point should be addressed proactively. In addition to the protective hood, consider other measures to minimize the risk of water damage to the electrical equipment. This might include installing drip shields, sealing conduit penetrations, and providing adequate drainage in the room. The goal is to create a multi-layered approach to water protection. Review the manufacturer's specifications for the main distribution panel to ensure that it is suitable for the intended environment and that it is installed in accordance with the manufacturer's instructions. The manufacturer may have specific recommendations for water protection or other environmental considerations. Explore the possibility of using alternative fire suppression systems such as clean agent systems, which do not use water. These systems can be more effective at suppressing fires in electrical equipment without causing water damage. Evaluate the overall fire risk assessment for the electrical room. This assessment should consider factors such as the type of equipment installed, the occupancy of the building, and the potential for ignition sources. The fire protection system should be designed to address the specific risks identified in the assessment. In some cases, it may be necessary to conduct a fire test to evaluate the effectiveness of the chosen fire protection system. This test can provide valuable data on how the system performs under realistic fire conditions. If the electrical room is located in a critical facility, such as a hospital or data center, it may be necessary to implement additional fire protection measures, such as redundant fire suppression systems or enhanced fire detection systems. These measures can help to ensure that the electrical system remains operational even in the event of a fire. Ensure that all personnel who work in or around the electrical room are properly trained in fire safety and emergency procedures. This training should include how to operate fire extinguishers, how to evacuate the room safely, and how to report a fire. Regularly inspect and maintain the fire protection system to ensure that it is in good working order. This includes checking the sprinkler heads, the water supply, and the alarm system. Any deficiencies should be corrected promptly. Keep accurate records of all inspections, maintenance, and repairs performed on the fire protection system. These records can be valuable for demonstrating compliance with the code and for tracking the performance of the system over time. It is essential to foster a collaborative relationship between the electrical contractor, the fire protection contractor, the electrical inspector, and the fire marshal. Open communication and cooperation are key to achieving a safe and compliant electrical installation. The protective hood should be properly grounded to prevent the buildup of static electricity, which could create a fire hazard. The grounding system should comply with all applicable code requirements. Ensure that the hood is securely mounted to the wall or ceiling to prevent it from falling and causing injury or damage. The mounting hardware should be appropriate for the weight of the hood and the type of wall or ceiling material. The hood should be designed to allow for easy access to the electrical equipment for maintenance and repair. The design should also consider the need for adequate ventilation to prevent overheating of the equipment. If the hood is equipped with any electrical components such as lighting or ventilation fans, these components should be properly wired and grounded in accordance with the National Electrical Code. The electrical system should be protected by overcurrent protection devices, such as circuit breakers or fuses, to prevent damage from overloads or short circuits. The overcurrent protection devices should be sized appropriately for the electrical load and should comply with all applicable code requirements. The hood should be made of materials that are resistant to corrosion and deterioration. This is especially important if the hood is located in a damp or corrosive environment. The hood should be inspected regularly for signs of damage or deterioration. Any necessary repairs should be made promptly to ensure that the hood continues to provide adequate protection. The hood should be cleaned regularly to remove dust, dirt, and other debris. This will help to prevent the buildup of flammable materials and to maintain the hood's effectiveness. If the hood is removed for any reason, it should be reinstalled properly as soon as possible. The reinstallation should be performed by a qualified electrician or fire protection contractor. Any modifications to the electrical system or the fire protection system should be documented properly and approved by the relevant authorities. This will help to ensure that the changes are made in accordance with the code and that the installation remains safe and compliant. All electrical work should be performed by qualified electricians who are licensed and insured. This will help to ensure that the work is done properly and that the installation is safe. The fire protection system should be designed and installed by qualified fire protection contractors who are licensed and insured. This will help to ensure that the system is effective and reliable. All electrical equipment should be listed or labeled by a recognized testing laboratory, such as underwriters' laboratories or electrical testing laboratories. This indicates that the equipment has been tested and found to be safe for its intended use. The installation should comply with all applicable codes and standards, including the National Electrical Code, the National Fire Protection Association standards, and local building codes. This will help to ensure that the installation is safe and compliant. A thorough understanding of NEC 110.34.F combined with a collaborative approach and careful consideration of all relevant factors is essential for achieving a safe and compliant electrical installation. Remember to prioritize safety and to seek expert advice when needed.